I'm going to be showing you the solutions to Math Kangaroo levels 9 and 10 for 2009. I'm going to be showing you numbers 2, 8, and 16. So let's start off with number 2. So the question is, what is the minimum number of points which have to be removed from the adjacent diagram so that in the remaining picture no 3 points lie in one line? So what the problem is saying is that how many points do we have to remove so that we can have uh, 3 dots in one straight line like this or like this. This is an example. So the first thing that comes to my mind when I think of this problem is that we need to remove the middle dot. Because that middle dot, if we remove it, then we can't have this line, this line, this line, and this line. That leaves us with only 4 other lines left, which is on the outside. So this is to show you, if we let's say we remove one of the corner ones, then we still have 1, 2, 3, 4, 5 lines that we can make. And if we remove an edge one, we only have 1, 2, 3, 4, 5 lines that we can make, or 6, which uh, which is more than the one in the middle. So we always need to keep the middle dot removed. So let's start off with A1. So if we only removed one dot from the middle, then we can still make 4 other lines. So A is definitely not it. It's the 2. So if we remove the middle dot and if we remove one of the edge dots, we can still make other lines. But if we remove the middle dot and a corner dot, we can still make lines as well. So 2 is not it as well. Let's do 3. So just say we have a middle dot and we have a edge dot and then we have another edge dot. So both edge and then a middle. We can still make 2 lines. Or let's say we have a edge dot and then we have a corner dot. We can still make a line. But let's say we have a middle dot and 2 corner dots. And then if you see, we can't make any more lines. But still see if we can do diagonal and an edge. If we do a diagonal and edge, we can still make a line. And the answer is 3 because there's no point on going any more forward because we already found the minimum number of dots that we have to remove. So now let's move on to 8. So the question is, the diagram on the right shows a solid made up of 6 triangles. Each vertex is assigned a number, 2 of which are indicated. The total of the 3 numbers on each triangle is the same. What is the total of all 5 numbers? So all the 5 numbers is basically this vertex, and this vertex, which each are all assigned a number. So now let me tell you what I think of this. So what I think is this vertex and this vertex must be the same because they have 1, 1, 5, and then they have an unknown value here, and then the back triangle is 1, 5, and an unknown value. So that means these two have to be the same because if this is 3, let's say this one is 3, and this has to be 3 as well, so that this side is 9 and the back side is also 9 because 3 plus 1 plus 5 is 9. So the back would also be 9. So these two have to be the same. And then let's talk about this bottom one. So this bottom one has to be 1 because these two triangles, they both share the same points, which is 5 and then the unknown value. So then the outer ones that are not the same or not the touching, they have to be the same value as well. So that if this is like 3 and then this side will be 9 and this side will also be 9 because 3 plus 5 plus 1 is 9. So now let's always keep this at 1 and I'll try to find these two values, the last two values. So let's try 9. So 1 plus 5 plus 1 is 7. So it's 9 minus 7 is 2. So that means the sum of these two has to be 2. And since they're the same, these two have to be 1. And if we add the sides of the triangle, this one is 3 and then this one is 9. So that means, and since these two match, 9 is not the answer. So let's try 12. So 1 plus 5 plus 1 is 7. So 12 minus 7 is 5. And then you divide it by 2 since these two are the same. So that's 2.5. Now let's have 2.5 here. 2.5 here. And now this side, the sum of this side is 6. but then the sum of this side is 8.5. So that means this isn't it. So 12 isn't it. And now let's try 17. Uh, so we have 17 minus 7 is equal to 10. And 10 divided by 2 is equal to 5. So we have 5 here, and then 5 here. So if we add them all on the sides, we have 11 here, 11 here, 11 here, and 11 here. And in the back, it's also 11. So that means 17 is the answer because all the triangles have the same sum. Now let's try 16. So if a square b is equal to ab plus a plus b, and 3 square 5 is equal to 2 square x, then what does x equal? So let's see what this question means. So this question means if we have a square b, and then we first multiply a and b, and then we add them. So let's try that with 3 and 5. So if we have 3 square 5, and then that basically means 3 times 5 plus 3 plus 5. So that would equal 15 plus 8, which is equal to 23. And now let's see 2 square x. So if we leave the variable in, let's put it on the top. So we have 2 square x, so that's equal to 2x plus 2 plus x. And since 2 square x is equal to 23, we can substitute that for 23 is equal to 2x plus 2 plus x. Now if we subtract 2 on both sides, so we can leave the variable on one side, we have 21 is equal to 2x plus x, which is equal to 3x. So we have 21 is equal to 3x. And then if we divide 3 on both sides, we have x, where 7 is equal to x. So 7 is our answer. Thank you for watching, and I hope you learned something today.